Okay, so we're now on day 5. Just reviewing the general theorem. What I'll do is I'll just quickly fill out the this sort of reviewing the general theorem. Give a quick little note about 1a and b, but there's I'll provide the solutions up on D2L, and ultimately I think rather than explaining it, you'll just need to look at it, and then I'll do a little bit of an explanation on page 2. You guys can get to work. So remembering that if we've got a binomial, two terms being multiplied to the put to the power of some exponent n, we can say that that becomes in expanded form n choose 0, a to the n, b to the 0, plus n choose 1, a to the n minus 1, b1, plus n choose 2, a to the n minus 2, b to the 2, plus dot, 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 all the way down to n choose n, a to the n minus n, or 0, b to the n. In sigma notation, this is written as epsilon r equals 0 to n of a to the r, a to the n minus r.
Mr. Sickley, please dial 3401. Mr. Tim Sickley, 3401.
Now we're going to apply this, so we're going to be practicing it a few times. Let me pause this. All right, so here we're going to be expanding binomials using the binomial theorem. Key thing here is to recognize our terms. So in this case, the a term is x cubed, the b term is 2y squared. So if, for example, I were to choose, not the first term, but let's choose the second term here, that would be 3, choose 1.
Mr. Pendergast or Mr. Hunter, please dial 3401. Mr. Pendergast or Mr. Hunter, 3401.
My first term to the power of 2, and then my second term, 2y squared to the power of 1. This would be the second term. My first term, 3 choose 0, x cubed, and then the, it's minus 2y squared. Minus 2y squared. Now, in this case, the minus 2y squared is to the power of 0, so it's just 1. I wouldn't really need to include it. But here I get minus 2y squared there.
The caretaker, please come to the main office. The caretaker to the main office.
When this gets expanded, 3 choose 0, coefficient is 1. Then that becomes x to the power of 3 to the power of 3 is x to the 9. Here, 3 choose 1 is 3. And then x to the 6. And then minus 2y squared. I'm posting the actual solutions up online, so you'll be able to see that. Same thing happens here. In this case, our a is equal to 2 over x squared. We can also write that as 2x to the minus 2. And our b is equal to the square root of x, which we can also write as x to the 1/2. That might be easier in solving the problems. Then finally, on the last page, in the expansion of x plus y to the 9, determine each of the following. The number of terms in the expansion. So remember, if Pascal's triangle, if I'm in the 0th row, the exponent were 0, I'd have 1. If I was in the first row, I would have 1 and then 1, right? I'd have 2 terms. So in other words, I have 1 more term than the row that I'm in. So if my exponent is 9, that must mean that I will have 10 terms. The value of k in the term 36x to the k, y to the y cubed. Well, our exponents have to add up. The exponents here have to add up to our exponent there. This simply means that k plus 3 must equal 9, or in other words, k would be the power of 6. X to the 6, y to the 3rd. The coefficient of the 4th term in the expansion. So that is simply going to be in our calculator. We're doing 9. The fourth term means that we are choosing, fourth term means that we're choosing 3. 9, choose 3. The first term is when I'm doing 0. Second term, choosing 1. Fourth term when I'm choosing 3. So that's 9, choose 3, which is equal to 84. Sorry, I had to check my Pascal's triangle. And so finally, we're asked to rewrite this in the form a plus b to the n. Well, I can see that my a has got to be an x, and my b has got to be over here with my y. Given that my exponent is 6, what do I know here? And that's going to be, I'm going to have some sort of, my exponent n is going to have to be equal to 6. I can also confirm that because I got 1, 2, 3, 4, 5, 6. I've got 7 terms, right? There's always one more term than exponents. So I'm going to have something that's going to be up to the power of 6. My first exponent is going to be some sort of a value of x, because the first term is always just the value of a to the power of n. But these other terms are a little more complicated because I'm getting some coefficient here. I'm getting alternating negative, positive, negative, positive. And I can see that in my final case here, I'm getting a 64. So that must mean, given that it's, I've got to have some value, I'm going to call it, I'll just put a question mark y to the power of 6. We know that y to the 6 is being satisfied, but some value, which I've used as a question mark to the power of 6, has got to equal 64. In other words, my question mark is going to be the 6th root of 64. And that is equal to 2, because 2 times 2 times 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the 6th root of 64 is equal to 2. That must mean that my b term is 2y. 2y. But it's not quite, I'm not quite done yet. Because if it was positive 2y, then I would always be getting positive terms here. And I'm getting alternating positive and negative. So that must mean that I've got a negative 2y. And every second term, I'm getting a negative times a negative, which is generating my positive value. So summary of that, what do we know? We knew that 7 terms. There are 7 terms. Therefore, n is 6. First term in our expansion, it should always be a to the n. And that again tells us that n must be 6. Final term. In this case, we're told it's 64y to the 6. And we know that that's got to be equal to b to the 6. So this allows us to solve what b is. This, because 64y, that's 64 multiplied by y to the 6. So we've got to figure out what this value here is. In other words, we're taking the 6th root of 64, which is 2. Term must be 2y. And then, since every other term is negative, term must be negative 2y.